Myself Sreevani, working as Assistant Professor in the Department of ECE in Institute of Aeronautical Engineering, Dundigal. So in this lecture, we are going to learn electric field intensity due to surface charge and volume charges. So in the previous lecture, we have learned one of the first application of electric field intensity due to line charge we have learned. The continuation part here, the second and third applications of electric field intensity is surface charge and volume charge. So let us go for the first one with surface charge. A surface charge. So an infinite sheet of charge in the xy plane with uniform charge density rho s means surface charges case. As we have learned in the previous lectures, there are three continuous charge distributions as rho L, rho S and rho V. As rho L stands for here line charge density and it is measured in coulomb per meter. Whereas rho S it is related to surface and it is measured in coulomb per meter square. And for OV it is coulomb per meter cube. Means whenever we have considered the charge density is related to line, then we need to consider only the charge is considered along only one particular direction, if it is x direction or y direction or z direction. So now we are considering the second application of this electric field intensity as surface charge. Means we have to consider one plane. Let it be planes means we have to consider two directional plane. Hence it is xy plane or yz plane or xz plane. If we consider the plane as xy plane, there this xy plane is also called as z is equal to 0 plane. Means in that xy plane z is a constant one. And if you consider the plane as yz plane, there x is the constant one. Hence the other name for that is x equal to 0 is said to be x is the constant plane. And xz plane means y is the constant one. Hence xz plane is also called as y plane. Y equal to some constant plane. So this is the way we have to consider the first one as here surface charge. Hence consider one infinite sheet of charge in a xy plane. Means z is equal to, this is the plane is also called as z is equal to 0 plane. With a uniform charge density. Means throughout the plane the charge is uniformly distributed. Hence we consider that charge density as rho s. And the charge associated with an elemental area as ds. So area means we have to consider its surface. Hence that elemental area is denoted with its equivalent differential element as ds and it is given by here dq equal to rho s into ds. As we have considered in the case of line, that is dq equal to rho L into dl. In the similar way for the surface, the differential component of the charge is given by dq equal to rho s into ds. Now to analyze how much is the electric field exist due to this surface charge, means with an example we'll analyze that one. So consider one simple figure. Here is the figure and that is the figure is evaluation of the electric field E due to an infinite sheet of charge. So here we have considered two planes as plane 1 is representing with 1 and the plane 2 is representing with 2. Means planes means we have to consider two surfaces as surface 1 and surface 2. So here the P in the figure, that P is representing the field point where we are going to estimate the electric field intensity E and it is located at a point called 0, 0, H. Means we have to consider here z direction component and x component by y component becomes zeros. Hence the field point where we are going to evaluate this electric field intensity E is located at P of 0, 0, H. Means x component as 0 and y component as 0, then we have H component, then it is given by H. And this H is denoted with height of this plane we have considered and it is located along the z direction. And from this origin 2, we have been considered the first surface 1, then the distance is given by here rho. and from this field point 1 to the surface 1 to the field point P, the distance is given by R, right? So in order to estimate this electric field intensity E due to surface charge, we have considered this is the triangle path, right? So that triangle path, so these are the parameters. So from here, if you consider it as origin, and from 0 to surface 1, the radius is given by rho, and this h is the height of this one. So it is placed along the z direction, and from surface 1 to the field point P at where we are going to evaluate this electric field intensity E is the distance is given by R. So if you observe the directions of this one, h is moving towards the z and R is also moving towards the z direction, and the rho is directs towards this surface 1. So depending upon these three directions, we are going to consider vector addition and vector subtraction. Depending upon that, we are going to measure the vector components of this surface charge, right? So this is the figure. Generally, this electromagnetic waves are analyzed with a 3D wave. Hence, we have considered here XYZ plane. So this is X plane, and here it is the Y direction component, and it will be the Z, right? So to calculate that electric field intensity E due to surface charge, first we have considered the differential component of charge, that is dq equal to rho s into ds. Then from that we find the normal component as q, then consider both sides integrations, then here integration differentiation gets cancelled, then it becomes q, then integral s rho s into ds, right? Where charge is given by q and it is measured in coulombs, and rho s is the surface charge density and it is measured in coulomb per meter square. Then ds is the differential component of the surface, right? So now in order to find this electric field intensity E due to surface charge distribution, then we have to consider that E, electric field intensity E due to surface charge equation as E equal to integral S rho s ds by 4 pi epsilon naught r square into AR. So the electric field intensity, as we know that according to the definition of electric field intensity, it is defined as this force per unit charge. So if you substitute in place of this F as Coulomb force, and charges might be gets cancelled, then the equation becomes here Q by 4 pi epsilon naught R square into AR is the general equation for the electric field intensity due to a particular charge, right? So instead of substituting, now consider a point charge Q. If you consider three continuous charge distributions as rho L, rho S and rho V. Then already we have analyzed this rho L. Now we are analyzing this rho S. Hence, we substitute in place of this Q by, this is the equation. What is that? Q equal to integral S rho S ds. Now if you substitute in place of this Q by this entire equation in this, then the equation becomes E equal to integral S rho S ds by 4 pi epsilon naught R square into AR. So here, if we consider this is the equation for the electric field intensity for the surface charge distribution, here rho s by 4 pi epsilon naught are treated to be a constant, and we have to evaluate the ds, differential component of surface, and the distance from the surface 1 to the field point P, where we are going to evaluate the electric field intensity and the unit vector direction. So these are the three unknown parameters, and these three unknown parameters are evaluated from the previous figure, which we have already considered for the surface charge distribution evaluation. So now the contribution to the E field at a point P 0, 0, H. So this is the point where we'll be evaluating the electric field intensity E with a XY plane. Hence, Z is a constant plane. Hence, we have considered here X component as 0, Y component as 0, and the Z component as only for H. So, by the charge dq on the elemental surface 1. So, in the figure, we have considered two surfaces, elemental surface 1 and surface 2. So, from the surface 1, we have considered then the differential component dE. So, this is the previous one. integral component equation, integral s rho s ds by 4 pi epsilon naught r square into AR. Now, if you find its differential component, dE equal to dq by 4 pi epsilon naught r square into AR. Then if you substitute in place of dq, what is that equation? Rho s into ds. So that from that equation, it becomes dE equal to dq by 4 pi epsilon naught r square into AR. Then from the figure, r dash equal to rho minus a rho plus HEZ. So to evaluate this one, we have to consider, just now we have considered the figure as this. Now if we observe from this triangle, we are going to calculate what is that r. Or, so in order to write the equation, first of all, consider this is a triangle. So here it is the elemental surface 1, and from that is located at origin. From origin to elemental surface area 1, the direction is given by, means that component is given by rho, and from elemental surface area 1 to the field point P, where we'll be evaluating the electric field intensity E, then distance is given by R, and from origin to the field point P, and this distance is given by H. So if you observe the directions of these two, H and R will be in the same directions, and rho direction is directs towards. See, rho direction and R direction are in the same directions, and H will be the opposite to that of these two. Hence, according to the vector addition, suppose if we have the one simple example, if we have a vectors like A, B, C, the directions of these three are will be the same. See, A to B it will be like this, B to C it will be like this, then C to A it will be like this. Means directions of all three are in the same, means we have to write the equation as A plus B plus C equal to 0. From this, C is equal to minus of A plus B. Right? So now in the similar way, if we analyze this is the triangle, so first we need to consider the directions of three components. So here rho direction and R direction will be in the same, and H direction will be opposite to that of these two. Hence, from this equation, we'll be writing the equation as R plus rho A rho equal to H AZ. Why? Because rho direction, it has a direct vector, means we have to consider its magnitude along with the unit vector called rho into A rho, and here from origin to this Z component, this field component is given by H, and it is located along the Z. Hence, from that figure, we'll be writing this as R plus rho A rho is equal to H AZ. So the same equation if you consider there, then from this R is equal to, take this rho A rho into this side, then it becomes minus of rho A rho plus H AZ. Right? So this is the equation which we have got from the elemental surface 1 to the field point P. Hence, the first equation to be obtained as here R equal to rho minus A rho plus H AZ. Right? So now from this, if you find its magnitude, so R equal to modulus of R dash. So for a variation purpose, we used to consider here R and R dash. So R dash is the vector form and R is the magnitude of this vector. So how we are going to find the magnitude of that one? Suppose if you have Z is a variable like Z is equal to XAX plus Y AY. Then if you find its magnitude, means modulus of Z is equal to root of X square plus Y square. In the similar way, here also R equal to root of rho square plus H square is the magnitude of this equation. Right? So now, and from that, one more unknown variable is here given by AR, and it is equal to R dash by R. Then R dash is given by here minus rho A rho plus H A Z, and R is the magnitude of that equation. It will be root of R rho square plus H square. Then from that dq. So dq equal to rho s into ds. Now in order to estimate that, we have to write the equation for this ds. So the field point P is located at what? 0, 0, h. Means we have to consider here z component only. Hence, the ds we are going to evaluate in the z direction. So these are the components which are given by cylindrical coordinates. So cylindrical coordinates means variables are given by rho, phi, z. So differential components means d rho, rho d phi and dz are the three differential components of cylindrical coordinate systems. Now, in order to find the vector direction as z direction, we have to consider rest of the two components. Hence, the formula for ds can be written as ds is equal to multiplication of these two, means rho d phi into az. Right? Suppose if you want to evaluate that field component along the phi direction, then we need to multiply these two then along the direction. Means in that case, the differential component ds formula becomes ds is equal to d rho dz into a phi. Suppose if you want to measure it in the rho direction, then the formula for ds is given by multiplication of these two. Hence, rho d phi dz along the direction as a rho. Like that, for the z direction purpose, we used to multiply the first two variables. Hence, the formula for the differential component of surface ds is given by rho d phi into az. Okay, so hence dq equal to rho s into ds, which is equal to rho s into rho d phi. Okay, hence by considering all means dq, then ar and vector r, then all we need to substitute in the electric field intensity E equation as E, or differential component equation dE equal to dq by 4 pi epsilon naught r square into ar. So from this, what is dq? Rho s into rho d phi by 4 pi epsilon naught is a constant, then r square. So r is given by root of r square, rho square plus h square, and ar. The formula for ar is here r dash by r. What is r dash? So that is given by minus rho a rho plus h az. So all these assumptions we need to substitute it in dE equal to dq by 4 pi epsilon naught r square into ar. Right? So now we substitute all this into this equation. Then rho s rho d rho. This is the equation. Rho s rho d phi into, what is that r here? Ar means r by modulus of r. Hence that r dash equation is given by minus rho a rho plus h az by 4 pi epsilon naught into. So in place of r by r is there. In the formula itself we have r square. So if you multiply that with r, then it becomes r cube. And what is that actually r? This is rho square plus h square under root. So hence it is cube root of r. Hence we can write it in the denominator as 4 pi epsilon naught into rho square plus h square whole power 3 by 2. Right? So from this we will be evaluating the electric field intensity E along the z direction. Why? Because the field point P is located on the z component. Hence E equal to integral is dEz. So here differentiation integration gets cancelled. This becomes electric field E in z direction component. Hence Ez is equal to integral S dEz equal to. Hence, what we have considered in the previous equation, and surface means what are the two differential variables. Previously, we have written that dq equal to rho s into ds. Then formula for ds means ds is equal to rho d phi az. So here the two variables are rho and phi. Hence, by default, we know that rho is the variable which is varies in cylindrical coordinate system. That is 0 is less than or equal to, rho is less than or equal to infinity, and phi is the variable which is ranging from 0 to 2 pi. Hence, rho and phi are the two variables. Hence, we are integrating that with phi and rho. Hence, rho is by 4 pi epsilon naught is treated to be as a constant. Then integral phi equal to 0 to 2 pi. Then d phi, then rho equal to 0 to infinity, and here rho variables are h rho d rho by rho square plus h square whole power 3 by 2 into az. Okay, so if you consider the constant terms and integrating with respect to the respective variables as phi and rho, then the above equation becomes, so rho s into h means h is a constant, hence we will be considering it as out of integration. Then rho s into h by 4 pi epsilon naught, and if you integrate here, integral phi equal to 0 to 2 pi d phi, then integration result as phi. We substitute limits as 0 to 2 pi, then it becomes 2 pi. Hence rho s h by 4 pi epsilon naught into 2 pi, then integral rho equal to 0 to infinity, then rho square plus h square whole power minus 3 by 2. Okay. And this az. So here in the numerator, if you observe, rho and d rho is the remaining terms. So for that rho d rho, I will be writing this one half into d rho square means, so there is a formula that is 1 by 2 into d rho square equal to, let it be 1 by 2 is a constant here, 1 by 2 into d rho square can be written as 1 by 2. So differentiating with respect to this one, then it becomes 2 rho d rho. 2 gets cancelled, rho into rho, d rho is left out. So instead of writing here rho into d rho, if you use half into d rho square, it is easy to integrate. Hence, instead of substituting rho d rho, we will consider here the term as half into d rho square. Hence, then if you simplify that equation, then rho s into h by 4 pi epsilon naught into 2 pi, then rho square plus h square whole power minus 3 by 2 into half d rho square. So integrating with respect to rho square means the formula becomes x power n, like that. Integral x power n into dx. Then what is the formula here? X power n plus 1 by n plus 1. Then substitute the limits. So in the similar way here, rho square plus h square whole power minus 3 by 2 by minus 3 by 2 plus 1 by minus 3 by 2 plus 1. Then substitute limits as 0 to infinity. Okay. So in order to integrate it in the easy way, we just consider here instead of in place of rho d rho by half d rho square. How half d rho square has written means half d rho square equal to, if you consider here 1 by 2 as a constant, then if you differentiating this one with respect to rho, then 1 by 2 into 2 rho d rho. So this 2 and this 2 gets cancelled, rho d rho can be left out. So in place of rho d rho, we consider here half into d rho square. Okay. So by integrating that one, then here 2 pi gets cancelled, rho s into h by 2 epsilon naught is left out. Then rho square plus h square whole power minus 3 by 2 plus 1 becomes minus 1 by 2, by here also minus 1 by 2, and limits are 0 to infinity. Then rho s into h by 2 epsilon naught into, so here this minus 1 by 2 becomes here in the numerator 2, hence it is minus 2. Then rho square plus h square whole power minus 1 by 2. Then if you substitute in place of this one rho square by infinity one time and next time as 0. Hence it becomes means 1 by rho square plus h square. So this is rho square plus h square whole power minus 1 by 2 can be written as 1 by root of rho square plus h square. So this 1 by 2 to be considered as under root of term. So there is a negative, for that we will be considering it as 1 by root of rho square plus h square. Hence minus 2 rho is h by 2 epsilon naught into 1 by root of rho square plus h square. Then we substitute limits as 0 and infinity. So 2 gets cancelled, minus rho is h by epsilon naught into. So if you substitute in place of rho square by first time as infinity, so something by infinity minus of 1 by square root of, we substitute rho square by 0, then remaining is h square. Okay, so square root gets cancelled, and if you multiply this one, something by infinity means its value is 0. So 0 minus, already here negative is there, So minus of minus becomes plus, then rho s into h by epsilon naught into h. So h gets cancelled, rho s by epsilon naught. Okay, so like this, the E equation to be obtained as E equal to rho s by 2 epsilon naught into Az. So why it is Az understood? I think so. Why? Because we have considered the electric field intensity E direction in the Z component. Hence, E equal to rho s by 2 epsilon naught into Az. Okay. So next is, in general, for an infinite sheet of charge means E equal to rho s by 2 epsilon naught into An, where An is the unit vector normal to the sheet. So if it is for z direction, that An is replaced by z. If it is for phi, A phi. If it is for rho, it will be A rho. So in general, for an infinite sheet of charge, that electric field intensity E due to surface charge is given by rho s by 2 epsilon naught into An. Okay. So if we consider one simple example, so for a parallel plate capacitor means we'll have two charges like plus Q and minus Q. These are the two conductors which are having two charges, as throughout this conductor this plus Q is distributed, and throughout this conductor minus Q is distributed. Hence, we'll consider for a parallel plate capacitor, the electric field existing between the two plates is having equal and opposite charges. So magnitude wise these are the same, and direction wise these two are different. That's why it's having equal and opposite charges. Magnitude is same and charges are to be different. And it is given by here E equal to rho s by 2 epsilon naught into An is for plus Q, and minus of rho s by 2 epsilon naught into minus An is for minus Q for a parallel plate. Then here minus into minus becomes plus, then rho s by 2 epsilon naught into An plus rho s by 2 epsilon naught into An. So 2 rho s by 2 epsilon naught into An plus An. Then it becomes rho s by 2 An by 2 epsilon naught. So this 2 gets cancelled. Rho s by epsilon naught into An is the general unit vector normal to the sheet. So this is the way we consider one simple application of this as parallel plate capacitors case. If we find the electric field intensity E due to surface charge, hence that equation becomes rho s by epsilon naught into An. Right? So this is the way we have evaluated electric field intensity E due to surface charge. And the third application of electric field intensity as volume charge. Right? So the volume charge distribution with uniform charge density rho v. So previously for line charge we have considered rho l, and for surface charge we have considered rho v. Now it is for volume, hence the charge density is given by rho v. Then the charge associated with that elemental volume dV is given by dq equal to rho v into dV. So previously how we have written the same charges, rho l into dl for line, rho s into ds for surface. Now it is for volume, hence dq equal to rho v into dV. Okay. So this also will be analyzing with simple diagram. So this is the figure which is to be considered for evaluation of the electric field E due to a volume charge distribution. So for the volume means we have to consider three directions as x, y, z. And the differential components in cylindrical means dx, dy, dz. And if you consider it for cylindrical, then d rho, rho d phi, and dz for cylindrical. And if it is for spherical, why spherical means we have considered here one spherical region. So for that, differential components are given by here. Generally variables are r theta phi, and the differential components are dr, r d theta, and r sin theta d phi. Right? So according to this, if you consider the volume, we need to multiply three variables. So r into r is already r square sin theta. Then differential components as dr, d theta, and d phi. Right? So these keep in mind this in order to evaluate this dq, we have to consider spherical region components as r theta phi, and the differential components as dr r d theta and r sin theta d phi, and volume is given by dv, differential volume component as dv equal to r square sin theta dr d theta d phi. Okay, so from this figure, how we are going to estimate? So from this, the field cubical object which is placed at dv at a variables called r dash theta dash phi dash. So previously we know that r theta phi are the three variables for spherical coordinate system. Hence we differentiation purpose, we just consider instead of r theta phi by r dash theta dash and phi dash. Okay, so and the P where we'll be evaluating the electric field intensity E, and it is located at 0, 0, Z. Here also only we have considered Z component, and the field point is located on the Z. And from this origin to the field point P, distance is given by Z, and this cubical object at dv to this point P, distance is given by R, and from here origin to this object, r dash is the distance, right? And angle which will be measuring here from this to this is phi dash, and from here it is theta dash, right? Throughout the spherical region, this rho v means volume charge density rho v is uniformly distributed, right? So from this figure, we have considered the differential component as dq equal to rho v into dv, right? So from the analysis part here, the total charge on the spherical of sphere of radius a. So previously we have considered dq equal to rho v into dv. Now from this q equal to integral v rho v into dv. So what is the formula for dv in spherical region? Just now we have seen that is dv equal to r square sin theta dr d theta and d phi. So dq equal to integral v rho v dv is the formula, where if we consider rho v as a constant, rho v integral v dv, then if we evaluate this equation, then the formula becomes rho v into 4 pi a cube by 3. So how this equation has to be come means dv equal to, now consider this is the formula, then in this rho v into dv. So if you substitute integral v means we are integrating this one with respect to volume, means we have to consider 3 integrals. Why? Because 3 are the 3 variables. So for the spherical region, what are the variables? R, theta and phi. So what are the ranges of r, theta, phi? R equal to 0 to infinity, and theta equal to 0 to pi, and phi equal to 0 to 2 pi. So by default, the two angles are ranging from 0 to pi and 0 to 2 pi. Now here we have considered one assumption as with a radius of sphere which is having some finite. Hence, we just consider r value which is ranging from 0 to a. Now, these are the 3 variables, and if we consider rho v into dv, what is the formula for dv here? R square sin theta dr d theta and d phi. So, rho v is a constant. Now, r square sin theta dr d theta d phi are the 3 variables. So, if you are integrating this one with respect to r theta phi, so first one if you are integrating this one with r square, then r cube by 3 is the result. Then if you substitute 0 to a as a limit. And for sin theta, integration of sin is minus cos theta, and limits are representing 0 to pi. And for the phi, it is phi, then substitute limits as 0 to 2 pi. Hence, rho v into, in place of r by a cube by 3, into, instead of substituting, in place of pi theta, if we substitute pi and 0, minus cos pi, then minus cos 0 into 2 pi. So, which is equal to. So, if you simplify all equations in this, then you're going to get rho v into 4/3 pi a cube. So, this is the way this equation has come. That is q equal to rho v integral v dv. Result is 4 pi a cube by 3. So the field, electric field dE outside the sphere at P of 0, 0, z due to the elementary volume charge is given by here dE equal to rho v dV by 4 pi epsilon naught r square into AR. So this is the integral component. Now we are considering it for the differential. Hence dE equal to rho v dV by 4 pi epsilon naught r square into AR. So consider this as number 1 and this is number 2. Then from the figure r equal to az cos alpha plus sin alpha aero. See how this equation has written means. So previously this is the figure and here alpha is to be measured. Then from that we have written this r equal to. So what is that equation we have here? Az cos alpha plus sin alpha aero. So cos alpha. So cos alpha, how will be measuring cosine angle means adjacent sides. What is the adjacent side for this z? And opposite side for this is rho. Hence will be written that equation for r as here r equal to az cos alpha plus sin alpha into aero. Right? So remember this equation r equal to az cos alpha plus sin alpha into aero. Now due to the symmetry of the charge distribution, why? Because throughout that spherical region, the charge rho v is uniformly distributed. Hence, due to that symmetry of the charge distribution, the contribution to Ex or Ey are added up to 0. Then we have left out with only Ez component. Hence, the P means where we are going to evaluate this electric field intensity E is located at 0, 0, z. That's why these two becomes 0, H component only left out, hence Ez is given by. Okay, so Ez is equal to E dot Az, where E is the magnitude and vector direction as Az. Simply we'll written, we have considered that equation as Ez equal to E dot Az equal to, and that is the equation. From our equation we have considered what is that? Cos alpha Az plus sin alpha aero. So we have only z component means the aero component becomes 0, hence integral z dE cos alpha is left out. Now what is the dE actually? Rho e by 4 pi epsilon naught, then integral v dV cos alpha by r square. So in place of cos alpha, as it is cos alpha, and in place of dE what we have considered as dE equal to dq by 4 pi epsilon naught r square into AR. Then instead of, so in place of dq if we consider the dv rho v, then it becomes rho v by 4 pi epsilon naught integral v dv cos alpha by r square. Okay. So again in this, in order to estimate the electric field intensity E due to volume charge, we have the variables as here dv, cos alpha and r square are 3 unknown variables. Again, from the figure, we have to evaluate the equation for dv and the equation for cos alpha and the estimation value for the r square. So again, we need to derive expressions for dv, r square and cos alpha. So to write the equations here, dv, r square and cos alpha, then as we know that dv, the formula for differential volume component in spherical region as r square sine theta dr d theta d phi. So differentiation purpose we use here the variables as r dash, theta dash and phi dash. Hence dv equal to r dash square sine theta dash dr dash d theta dash and d phi dash. So this is the formula for the dv. Now we'll be considering r square and cos alpha. So for that, here applying the cosine rule to the above figure means from the figure, suppose if you consider one triangle as like this, then if you consider here A, B, C are the lengths of the vector and A, B, C are the two measuring angles. Now from this equilateral triangle, if you apply cosine rule, then applying cosine rule to the above figure, from the figure. So there, if you observe here in the figure, this is the figure. So from this, consider this as the triangle and here is the triangle. So for the triangle and theta dash, r and z and alpha to be measured. Now from that, if you want to measure how much is from origin to this cubical object, this distance is given by r dash. So if we consider this as the triangle, from the triangle we'll be writing cosine rules. So here, if you apply first cosine rule to the above figure, then r square equal to. So r square equal to z square plus r dash square minus 2zr dash cos theta dash. And for small r dash square equal to z square plus r square minus 2zr cos alpha. Means, suppose if you want to measure the angle as here a square is equal to b square plus c square into, what is that angle which we are going to measure here? Minus 2bc into cos that respective angle. Suppose if you want to write the equation for b square equal to a square plus c square minus 2ac into cos of that a or b or c. Then similarly for c square equal to a square plus b square minus 2ab cos of that c square. So like that, if you consider the equations for cosine rules, then r square equal to z square plus r dash square minus 2zr dash cos theta dash, and r dash square equal to z square plus r square minus 2zr cos alpha. Okay, so again simple analysis for that. Here is the alpha and here is the theta, and here capital R is there. This is the distance as r dash, and here it is the z. So from this triangle we will be writing the equations for r square equal to. So r square equal to, opposite two sides are z square plus r dash square minus 2z r dash into. So we are measuring this for, hence we have to consider it as opposite angle for that is cos theta dash. So generally these are the variables theta dash, r dash and phi dash we have considered, hence r square equal to, this is the equation. Now from that, in the similar way, we will be writing the equation for r dash square. So r dash square means z square plus r square minus 2zr into the opposite angle as cos alpha. Hence, this is the way we have written the cosine rules for, from the figure. We apply cosine rules. These are the two equations are to be obtained as r square equal to z square plus r dash square minus 2zr dash into cos theta dash. Then r dash square equal to z square plus r square minus 2zr cos alpha. Now to evaluate the above equation, means previously what we have considered the electric field intensity E. Then in that you just substitute r and r dash. Then we express cos theta dash, cos alpha and sin theta dash d theta dash in terms of r and r dash. Right? So from these two equations, if you write the equations for cos theta dash and cos alpha. So from this equation, cos theta dash equal to, so z square plus r dash square minus r square by 2zr dash. In a similar way, from this equation, cos alpha equal to z square plus r square minus r dash square by 2zr. So consider these are all the respective equations. Now substitute all in the respective. And the differentiating. So previously we have considered the equation for dv as r dash square sin theta dash dr dash d theta dash and d phi dash. So here sin theta dash and d theta dash is the another one. So to in order to consider that, we just consider the equation for cos theta dash. That is the equation which we have got from this as z square plus r dash square minus r square by 2zr dash. So from that, if you differentiate that equation, sin theta dash d theta dash is equal to r dr by zr dash. Now as so theta is changing to theta to r. Now these theta variables are ranging from generally 0 to pi, hence r is also going to change according to this 0 to pi, z minus r dash to z plus r dash. So now we substitute in place of that theta dash by first 0. So that equation means previously cos theta dash is equal to, what is that equation? Z square plus r dash square minus r square, z square plus r dash square minus r square by 2zr dash. Okay. So from this, we'll be considering this one with respect to theta, means differentiating this one with respect to theta minus sine theta dash into d theta dash, which is equal to. So here, these are the two which are treated to be constants. Hence, this becomes minus 2r dr by 2z r dash. So 2 gets cancelled, minus minus gets cancelled. Then sine theta dash d theta dash is equal to r into dr by z into r dash. Now this is the equation which we have got. Now consider the same equation in that you just substitute theta dash by first 0, then next by pi. Now first if we substitute theta dash by 0, so then it becomes cos 0 equal to z square plus r dash square minus r square by 2z r dash. Now cos 0 means its value as 1, which is equal to. Now if you simplify like that, capital R is equal to, it becomes z minus r square equal to z minus r square whole square, then r equal to z minus r dash. Similarly, if you substitute in place of theta dash by pi, then it becomes z plus r dash. Like that, the theta which is varies from 0 to pi, hence r is varies from z minus r dash to z plus r dash. Hence, by substituting all that in Ez, rho v by 4 pi epsilon naught integral phi equal to 0 to 2 pi d phi, then r dash equal to 0 to a r dash square dr dash, then capital R equal to z minus r dash to z plus r dash, and r dr by zr dash into cos alpha. This is the formula, z square plus r square minus r dash square by 2zr into 1 by r square. In the formula itself, we have this extra term called 1 by r square. Now if you simplify this equation completely, so here is the, so rho v by 4 pi epsilon naught z square 2 pi. So this is the result which we have got, integral phi to d phi. Then limits are 0 to 2 pi. Then it becomes 2 pi. R dash equal to 0 to a r dash dr dash. Then capital R equal to. So this is the equation which we have left. Now if we substitute limits and all, simplification, then rho v by 4 pi epsilon naught z square. So 2 pi, this 8 pi gets cancelled. Hence rho v by 4 epsilon naught z square integral r dash equal to 0 to a 4r dash square into dr dash is left out. Now 4r dash square. So consider again this 4 as outside. Then r dash square means r dash cube by 3 is the result. If we substitute 0 to a, then a cube by 3 as left out. So rho v by 4 epsilon naught z square into 4/3 pi a cube. What is it? 4/3 pi a cube, volume of the sphere. Hence, we just replace 4/3 pi a cube by q. Hence, it is charge q, and q by 4 pi epsilon naught z square into az is the left out. So, and this is the equation which is valid for, means, and the result is obtained for E at a particular point P at 0, 0, z. Right? So, if it is in general, how we will be writing this electric field intensity E equation means the symmetry of charge distribution, and the electric field at P of r theta phi means r is also one variable, theta is also one variable, and phi is also another variable. Now, if you want to express it in terms of r, hence E equal to q by 4 pi epsilon naught r square into ar. Instead of r theta, so a theta. Instead of theta phi, it is expressed in terms of E equal to q by 4 pi epsilon naught r square into ar. Right? So this is the way we have evaluated the electric field intensity E due to volume charge. So in all the cases, how we have evaluated electric field intensities due to line surface volume charges means, first we have evaluated the first point charge, differential component of the charge for line as rho L into dl, and for surface rho S into ds, and for volume it is rho V into dv. Now general formulas for E is given by, for line it is integral L rho L dl by 4 pi epsilon naught r square into ar, and for surface integral S rho S ds by 4 pi epsilon naught r square into ar, and for volume integral V rho V dv by 4 pi epsilon naught R square into AR. So in that, all the unknown parameters are evaluated from the considered figure, that is dl r square AR in the first case, ds r square into AR in the second case, dv r square into AR in the three cases. So this is the way we have evaluated the three applications of electric field intensity due to line charge, surface charge and volume charge. Thank you everyone. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.